Hey, hello everyone, and this is Riaz and Setu here. We are going to talk some basic stuff and some advanced stuff around how to go ahead and manage some external threats in the cloud and also especially in the managed Kubernetes environments. So when we talk about Kubernetes and when you talk about Kubernetes pen testing, the first guy who comes to my mind is Riaz bro, and he has been pioneering Kubernetes clusters for a while now, and so we are. I mean, I'm glad to have him today here to hear us. Thanks for
Like,
joining.
thanks, Atul. Glad to be here.
Perfect. So, I mean, I'll give a quick intro for the folks who don't know me. I'm Setu. I'm the CTO and co-founder of Risk Risk is an external threat exposure management platform. And Riaz, you want to go ahead and give a quick intro about yourself now?
Sure. My name is Riaz. I co-founded Cloudl along with Akash, and I head the security team there, the R&D and the security team at Cloudl. Cloudl is a suite of security scanners for cloud providers, right, and cloud cloud-related resources. Cloud is currently capable of detecting over 500 odd misconfigurations across various providers and their cloud assets and resources. And all we need are read-only credentials, right, for the cloud, and we'll be able to scan and show you what's misconfigured within your cloud. So that's about us.
That's nice. That's nice. And with that, right? I mean, Riaz, I have a basic question for you to start with, Riaz. And this is
Hmm.
one of the questions which many of our audience were also interested in the initial poll. I sent out a poll like, what are the questions that you guys like?
Oh,
And then this is the first question which had the maximum number of votes on it.
uh,
And it is basically like, what are some common misconfigurations and vulnerabilities that
ah,
you normally see a lot during your pen testing and during your engagements when it
sure.
comes to pen testing the cloud environments or pen testing the managed Kubernetes clusters?
Sure, sure. I understand why this is a popular question. The answer to this itself is a 3-day training, right, at most conferences. But to give you like an overview of what I see frequently when we're doing pen testing for clusters, and even when customers run cloud on their Kubernetes environments, the we have to understand the most primary requirement for attackers is to be able to see stuff, right? So all attackers need to see what they're going to be attacking. And there are obviously blind kind of attacks are there where the attacker plants something and there's a callback back to their servers, and there's a remote exploitation of stuff that is happening. But all of that is blind. But it takes a lot of guesswork, user intervention, things like that. With
Yeah.
Kubernetes and cloud services, things are not very far off from what we've been observing throughout the industry, anyways, right? From for the last 2.5 decades. As long as there's an attacker vantage point, misconfigurations are going to be there, right? Any API-driven system, like all cloud providers in Kubernetes, they're going to be vulnerable to I categorize them in two buckets, right? To owing to one of two things, either security misconfigurations and poor authentication authorization related flaws, right? Some external misconfigurations that we see commonly with customers for Kubernetes clusters, in our experience also have been like API is visible. The customers are not aware that their Kubernetes cluster was exposed to the internet, right? On their 8443 or 443 or whatever port the cluster was listening on, that was exposed to the internet. Although there was authentication in place, but exposure of the cluster tells a lot about what kind of environment they were running. In some cases, we've also seen read-only kubelet, the 10255 port, to which you can make an unauthenticated request, and it will give you read-only information about the cluster. And that also we've seen in a couple of cases. Older versions we've seen for Kubernetes. In one case, we saw an overprivileged anonymous user that was able to read right into a particular namespace for whatever business decision this was created in, right? This is an extremely dangerous
Yes.
vulnerability, in my opinion, right? So because an attacker can create a pod and then shell into the pod, exec into the pod, and then gain access to other things within the cloud, because the clusters sit on top of what cloud providers services API services provide, right? So gaining access to a container and to the cluster allows like an easy entry into the cloud environment itself. Right? So
Yeah.
common things. Yeah.
Nice. I mean, when in my previous role, right, not in the current role, so I was a consultant. So
Mm.
when we talk about consulting, the first thing I was doing a lot of stuff is not in other cloud providers, but I was doing a lot of EKS uh,
Mm.
pen testing and EKS auditing sort of things. The things which I've told are like the most common ones. The dashboard being exposed to the internet, and currently we are also still seeing because last year I think Viz has published a report, and the report is like around Kubernetes security. That it's like they say that out of 100 Kubernetes clusters, 68 or 69 of them are like public Kubernetes clusters. Irrespective of them whether they have any intention of being publicly available, is there any requirement or not, it always goes to Kubernetes public clusters, even the nodes and other things. And when we internally did a due diligence, like dive deep on what is the reason for this, it's basically when anyone goes ahead and creates a Kubernetes cluster within most of the popular cloud service providers, it opens up to the internet by default.
Yeah, yeah,
It's
yeah.
pretty much most of the documentations as well, right? When it comes
Huh,
to Helm chart documents, and when
huh,
we talk about some deployment documents, some
huh,
services running on Kubernetes clusters, those general documents, even those
huh,
documents recommend to use the 0.0.0.0
huh,
as the initial deployment guidance. And developers would love to follow the documentation, and that documentation did not have any notes around the implications that by making this 0.0.0, you are exposing a Kubernetes cluster to the internet, or you're exposing your services to the internet, and that will lead XYZ complications in future in terms of security. I mean, there
I'll,
is nothing like that.
I'll add something. The fun thing is, right, and I say fun because I always look at things from let me break this thing from a point of view, right? There's no other thing I know to do, right? I always tend to look
Yeah.
at the offensive side of things. The thing that we miss, right, is back in the day when we had on-prem systems, the person who was going to set up the server had knowledge of the network layer, so
Yeah.
they would understand exposing ports, exposing services, firewalls, what are your private network subnets, your VLANs. All of these things are understood by the person who's creating the hardware, the servers on top of the hardware that is given to you on prem. With the cloud, you have one-click deployments. You have APIs that are being used to create your infrastructure. You use Helm charts, you use Terraform, you use CloudFormation. Doesn't matter, as long as there is automation and all of these things are being deployed. The requirement to understand the underlying concepts of cloud security or cloud in general is diminishing, right? And it's not a good thing or a bad thing. The people who are doing this are the people who are running the business, the core infrastructure of the business, and it's a requirement by the business. But no
Yeah.
business is going to be like, hey, you need to have a CISSP to be able to deploy a Kubernetes cluster. No, that requirement doesn't exist anymore. So people are coming, they're deploying, they don't understand the network layer, and you have clusters that end up being public. There's another thing there, because if you, I mean, our audience is also, if try this as an experiment, and you didn't hear this from me. If you want to look at Shodan, for example, and if you just go search for 10255 port on Shodan, right, or if you have mass scan, spin up a server and scan the entire internet for 10255 port, you'll see that a ton of servers exist, right, with Kubernetes kubelet ports that provide read-only information. Right, and as a research project, you can take that up if you want. If you're interested in presenting at conferences, for example, that's a good conversation to have. But the wide scale availability of information on the internet that has been misconfigured is something that we should all be thinking about, right?
Yeah. Yeah. And we have a question from the, like, I mean,
Huh.
the Kubernetes hacker here. So,
Hmm.
I mean, Riaz, what are your go-to tools when you scan for vulnerabilities in the Kubernetes clusters?
I obviously use Cloudl. Our Cloudl scanner for Kubernetes does a very good job with Kubernetes clusters. Um, Beyond that, I also tend to refer to the if I'm like doing like a audit, for example. Although Cloudl does the CIS benchmarks, but in case some variation has been added or there are new things that have been keeping in touch with the CIS documentation, for example, that itself is a pain as product developers go. But yeah, referring back to the CIS documentation and Cloudl is a good option that you could use to look at Kubernetes vulnerabilities. And there are, I'm on the top of my head, I don't remember names, Kubebench and these tools also. Folks at I'm forgetting the name, the folks who wrote the tools. But Kubebench is something that comes to my mind. There have been others. Nmap, for example, has a bunch of scripts that can be used to look at Kubernetes related issues. But because I understand the system, right, and there are about 15 or 20 odd things you'd look at from outside to the cluster. And if you have access, you're looking at a bunch of other things.
Yeah.
It's not very difficult to come up with a checklist that that you can use to automatically scan for vulnerabilities within the cluster.
Yeah.
Thanks,
So,
Aluru, for the question.
yeah. I mean, I have a follow-up question to that, by the way.
Ah,
So, in my engagements, I have seen once I have seen an Kubernetes API being exposed or kube proxy being exposed, and once I go to the API backslash secrets,
mm,
sometimes I mean, I get my hands on some
mm,
pretty interesting secrets in those environment
mm, mm,
variables developer
mm,
store.
mm.
So my question is like, once you get access to that, I mean, I did not do much post that because that's my engagement type of engagements I had. But I want to ask you, as like you do a lot of post exploitation kind of things, right?
Oh
So
yeah.
once you go beyond that, right, how
Mm,
often do you see network
mm.
policies being implemented, like port to port communications
Rare,
being blocked, or
rare,
the network applications being blocked with the help of namespaces? How often do you
rare,
see these things in real time?
rare, very, very rare, very rare, very rare. The Kubernetes by itself is not insecure. Okay, and there's a common misconception that if you're going to deploy Kubernetes, you're actually inviting security issues. No, Kubernetes by default has a lot of security built in place, right? But because your business design for your product requires you to have isolation within your namespaces, you can implement that using network policies. If you have Cilium or ViewNet or something like that as a network provider built into your cluster, you can use that to create policies. You can use pod security to enable stricter controls over what kind of pods are going to be deployed and things like that. So security features, there are a ton of them, right? But because again, coming from the industry point of view, where I'm a business, we've got funding, we need to go live with this product yesterday, right? And the best, fastest way to do it is you spin up a
Yeah,
GKE or an EKS and push our code there, put a load
yeah,
balancer in front, and it'll go to the internet, right? I have a private cluster, okay? It's not public to the internet, but hey, you have an app that is vulnerable to SSRF and that is
yeah,
exposed to the internet using a load balancer. That much
yeah.
is enough for an attacker to be able to reach to your container and they pull out your node credentials, right? For example.
Yeah. I
So,
mean, talking about the containers, right? I
uh,
think we have one of the questions from our audience, like spot on. Like, what
hmm.
are the techniques that you normally use to break out of Kubernetes containers?
um, so this involves, I mean, obviously multiple things based on where I am within the country. So I have this approach when I do post exploitation, right? So I ask myself two or three questions: where am I? What environment am I in? Right? What can I see from this vantage point? Breaking out of Kubernetes containers by concept itself, if you can, so the idea of escape, right? There are multiple things, right? You can either find flaws within, and I'm going from most complex to the least complex, right? Find flaws within the container environment, the runtime itself, right? If you have a Docker bug, for example, or a CIO bug, you use that to jump out or exec code within the node and then get a shell into the underlying node that's running your container. Uh, the common ones that I use, I mean, not as advanced as these, but because of misconfigurations within the cluster, and these are far more common than using 0 days and 1 day or unpatched Docker Sierra Relay bugs. Um, One of my favorite is, and you can call it a breakout of a container because you now escaped the container layer and you've jumped into the cloud. I tend to find, and because secrets are embedded, I tend to find secrets in code. Once I've gained access to the container, I'm finding secrets in code. I'm finding secrets. Say there have been database. The most common ones are to find IMDS instance metadata version endpoints and figure out your instance profile credentials and then dump that and gain access. Right. So that's one. That's the more commonly known one. There was a fun pen test I did where I was able to jump into a container and there was a config file which had database credentials. The database was a MariaDB or a MySQL server, not a RDS, but a server. And then using these credentials, I was able to exec into
Yeah,
the MySQL database and then drop right into out file from there and then load a library and then do fun stuff. Standard SQL injection, but now with the MySQL client,
yeah,
right?
yeah,
So anything that allows you to escape and execute commands or code outside of the container would be you'll be able to use that to break out of your Kubernetes container. Otherwise, you find your mounted volume points that are on the underlying node. You see if you can jail that and write to a sensitive file within the node and get that to execute things like that. So
Makes sense. Totally makes sense. Thanks, Nikhil, for the question.
yeah, sure.
So following up with that, right? So, what do you think? Like, which is, I mean, what is it? What do you think about a recent breach that involved Kubernetes environments or Kubernetes services?
Let me think.
And
This is
explain, like, what is your favorite one and how it was executed and how it was mitigated, etc. Something like that.
favorite ones there are. I mean, we keep hearing. See, to the audience, and again, you also from your experience, as I said, Kubernetes by itself is not
Uh,
insecure, right? And it's not vulnerable. It's a configuration that users end up doing. Um, Unlike AWS, for example, a long time ago, you could create a bucket. The S3 bucket would be public by default, right? So, or you would create a EC2 instance, and IMDS V1 would be applied to it.
yeah,
But Kubernetes in and recent attack is the context here. I think it was last week or something where I read this report where I think it was Open Metadata. There's a product called Open Metadata, which
yeah,
had about 4 or 5 CV 0 days RCs and authorization bypasses, and attackers were able to exploit these and gain access to the container that was running Open Metadata, and then
yeah,
they downloaded malware from some Chinese server and started mining crypto,
yeah,
on those. And obviously, they got caught because CPU exhaustion and things happened. The
yeah,
fun thing is that, and I call them fun things, obviously, my perception. Fun thing is that most people are able to compromise, and news media especially portrays it as, oh, Kubernetes got exploited and Kubernetes was hacked and your cluster was hacked. No, the entry point was a web app that got hacked, right? The entry point was an API service that was running as a container app, right, within the cluster. So
yeah.
even if you look at the shared model of responsibility and apply that to what is the Kubernetes cluster, the
Mhm.
cluster itself was secure, but the app made it insecure, right? So
Yes.
same example with this open metadata hack that Microsoft researchers actually published last week. I think that was a fun read because the attackers not only downloaded malware code and they tried to mine crypto, but they also sent messages out, I think, or put files saying that, hey, I'm very poor and this is my Ethereum address. Can you send money here? I need to buy a car. Things like that, right? So that was actually a hilarious read.
Yeah.
But again,
He wrote something like, "I don't want to do anything illegal. I just want to buy a car."
buy a
And I
car,
was
buy a
like,
house.
yeah. So that,
And
I mean, it's like, even when I mean, I did like, I read that article and then I went back to see like what was the root cause kind of a thing, because I always like to go out and read the documentation of the open metadata documentation, because internally we even use it because it's an amazing solution. It's an amazing
yeah,
solution
yeah,
to have that metadata of, it's a metadata database kind of a thing.
yeah, yeah, yeah.
So I read the documentation, and in the documentation of deploying deploying that application, they clearly mentioned that in the config file 0.0.0.0.
Yeah,
So
there you
they
go.
recommended their users to go ahead and deploy their application with
Yeah.
some admin ports exposed to the internet. So that's one thing. And then on the other side, right? Uh, we do. I mean, we do scan the internet a lot and then identify the trends and all these things at risk profiler. So one of the things is like Kubernetes clusters and other things that we do, because we do a lot of cloud attack surface management. Then other thing that we have noticed is there is also another breach that has happened. That is because of an open source framework which is
Mm,
popularly used for AI and ML
mm,
applications, running AI and applications in the Kubernetes clusters, and it's called as
mm,
like a Ray framework. It's a Ray framework.
mm,
Uh, I was reading like how big is this framework and everything. OpenAI used Ray framework to go ahead and train ChatGPT. So it's like an amazing, very popular and very powerful framework that is popularly used in the AI/ML space.
mm,
And one thing special about it is users normally use the Ray framework only
mm,
when it's a huge compute behind it.
mm,
So it's not just something like we're talking about one or two frameworks or one or two nodes or three or four nodes. It's like
mm,
40 to 100 nodes kind of an thing.
mm,
So that Ray framework had an CV, so
mm,
they called it shadow ray, and that shadow ray got exploited. what
Hmm.
happened was instead of in a normal use case in the open metadata and these type of other Kubernetes clusters, they are like one or two nodes, four or five nodes kind of a thing. These are like 40 to 100 nodes. So
Yeah.
this time, hackers got access to the crown jewel, which
Ah.
is like very precious with 40 nodes compute power. They started mining
Ah.
Monero. So I mean, most of the time, whenever I see a Kubernetes breach,
Ah.
I mean, cryptojacking happens a
Hmm.
lot, literally. So, I mean, we had like a couple of customers who are
Hmm.
using it, and then
Hmm.
immediately we created a signature, and then all those customers got notifications
Ah.
telling that this is a new service that we have observed, and there is an
Hmm.
active CV with a KEV database,
Oh,
active
nice.
CV is being exploited, so fix it.
Ah.
Kind of.
Nice.
So
Nice.
it's uh, it's a
Uh,
lot of
uh,
interesting
uh,
stuff.
Another one comes to mind. This is some time ago when uh, Tesla had, yeah, I think it was Tesla only. Tesla had a Kubernetes cluster exposed to the internet, and they had a Kubernetes dashboard, the Kubernetes dashboard app, right? That was exposed to the internet without credentials. So attackers were able to just browse to it and then run pods within the cluster. And they again, like all attackers who find Kubernetes because the computing power, start mining crypto. Bitcoin got halved last week, right? So it's even more
Yeah,
difficult to mine Bitcoin now. I
yeah,
think
it
last week or
is.
so it became half. But
Yeah.
Monero, Ethereum, you'd see a lot of these crypto mining malware coming from a lot of foreign nations, right? So that's always there.
Yeah, yeah, yeah.
Fun incident response that is.
Yeah, I did one more incident
Hmm.
response.
Ah,
That's basically right. They were the root cause at the end of the day. The root cause was they were their Kubernetes cluster was private. They secured on
ah,
all those things, but
ah,
they were using something called as Argo CD to manage
ah,
the deployments
yeah,
to the Kubernetes server. So
yeah, yeah,
that
yeah.
Argo CD was unauthenticated and then open.
Ah,
So
ah,
it's like instead of going ahead and getting shell in a Kubernetes server, going through the Kube API and everything,
ah,
the
ah,
attacker simply created a simple. I mean, they had like amazing automation. Once you
hmm,
update a repo,
hmm,
automatically Argo CD will pull that and then go ahead and deploy it and manage
hmm,
those no
hmm,
pods.
hmm.
So this guy, I mean, the attacker went ahead and they deployed,
Immersion.
yeah, minus the container images in it, and Argo
Hmm,
CD gladly took that malicious container image,
hmm,
deployed those pods in all the nodes,
hmm,
and they realized once their node utilization spiked and their application performance went low when they were doing the due diligence, they were seeing
hmm,
all these random pods being spinned up in the last 1 or 2 days.
hmm, hmm, hmm.
So, I mean, it's not just always the Kubernetes that will be an entry point. Sometimes all
Yeah,
these type of deployment
yeah,
solutions also
yeah.
act as an entry
I
point.
mean, in my experience, it's I would say if I want to put a percentage, it'll be about 25 to 30% will be an actual misconfiguration within Kubernetes that is exposed, and almost rest is going to be some app that somebody's misconfigured.
Yeah,
Authorization allows RC, allows file uploads, things like those that allow people to do RC. I've seen apps that allow you to drop into the container and execute code, right?
yeah,
A
yeah,
lot of these software coding software interview type companies, right? They
yeah,
allow you to run Python code, for example. You can drop into the shell and you're in a sandbox container. But if the
yeah,
container security is not put in the seccomp or your network policy and things like that, people would be able to escape that into the underlying node.
yeah.
Right?
I
So,
mean, one of our buddy, right?
mm,
This guy, I think it's Sriram. I think so. Sriram Sham, that guy.
mm,
So
mm,
what he did is like he was using Katakoda back then
mm,
before the O'Reilly acquisition has happened,
mm,
and the Katakoda gave them the permissions to go ahead and run code and all this kind of fancy stuff.
mm, mm,
So he was able to bypass it, and then he was able to run some arbitrary code which can lead to DDoS and create some outbound connections.
mm,
So in I think it's in 2017 or 2018, I think so. So
mm,
even I think he got some bug bounty reward. So it's been like for
mm.
ages now running
Yeah.
this container escaping
Kubernetes
mode.
at what version 1.3 now? No, it's 3.0. I think it got released last week. They have improved a lot, right? Security has been added left, right, center to Kubernetes. Far more difficult. Right? I have difficulty keeping up with the new changes that have happened in Kubernetes, and
Yeah,
it's like part of my core jobs.
yeah. I stopped tracking it like an year ago, man. Before
uh,
that, I mean, my job demands it, but now in a
yeah,
totally different, wearing a totally different hat. So
uh,
I stopped keeping track of it, but I just read the news and articles, this type
uh,
of things once in a while.
yeah,
I mean,
absolutely.
Riaz, I want to ask this question, Riaz. Like, you I have seen you pen testing
Hmm.
uh, during the data center times when
Yeah.
the applications were running on the on-prem data centers, and I have seen you pen testing when the applications are running in the cloud native Kubernetes environments as well. So, what is in your experience, right? What is
Hmm.
the major difference in terms of an external threat in both these cloud environments
Uh,
uh, and non-cloud environments in past?
does your question of external threats also count somebody storming into the data center with guns? Physical security is a thing, right? AWS
No,
wouldn't allow people to walk in
yeah,
and pick up a server and run away. But
yeah,
again, lots of differences. Physical security obviously being a big game changer, but even with see all cloud providers and Kubernetes managed, unmanaged doesn't matter. All of them rely on APIs, right? So
yeah,
um, I'm not talking about accessing the app, but even deploying the app, for example, maintaining, managing, shutting down, bringing up new servers, bring up the infrastructure required to host your production apps, right? All of them are still API driven. That is
yeah,
very new, right? And when compared to how data center stuff is being managed, if you earlier when you deploy, you'd SSH into the server, you'd like copy SCP files, you'd
yeah,
host. There's no containers. You'd host it in some directory on in the home. You'd have a user called app, for example. You'd put everything there, and you'd
yeah,
have you'd use IP tables to make sure that port 80 was open, nothing else was open, 22 was only visible to some. So there was a lot of configuration at the system level that was being taken care of, right? But now with the advent of cloud, you can have, and I've seen this as a common mitigation technique that, and again, as long as it works, it's fine. As a common mitigation technique that a lot of infrastructure folks do, saying that during an assessment, if we say, hey, we discovered SSH is open for your for the server, and there is no solution that where they will go SSH into the box and then apply IP table rules. There
yeah,
is a layer on top of that that sits. You have network firewalls, you have security groups, whatnot, right? Depending on what cloud provider you're using, and all of them provide the ability to slap a firewall rule in front of the server, not even touching the server, right? So that you don't have to change anything within the machine. You don't have to know Linux, for example. Linux commands, IP tables are very easily, you can screw them up. But clicking buttons and applying a firewall rule, wow, that's like amazing stuff, right? So that's always a interesting thing that I see. Um, I also I've seen that in a previous life where I was there was a server that I was maintaining, right? And it was a long time ago. We had an internal app running for the organization, and was like a CTF thingy that we were doing between two teams within the company. And this is almost 15 years ago, when the folks decided to flood the network instead of doing an attack. They decided to flood the network, and everything went down, right? And we were not able to access into our own boxes. So to be able to now stop the denial of service, I
yeah.
walked to the server and pulled out the Ethernet cable, right? Network attack stopped, right? And
Uh,
obviously, everybody was thinking at a level where they were like, hey, you know what, we should a network firewall and this and that, configure the router, allow them to drop VLAN packets. And I'm like, no, 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 hang on, there's a better solution. I'm sitting in front of the server, so I just went and pulled out the cable, right? And then I connected a monitor to the Dell box that I had, and I was able to log into the console, and then I had root
mm,
access right at the console. So I was able to then reset whatever SSH ban that happened, and then the
mm,
server's up in no time. And you can't do this now, right? And if your server is undergoing a denial of service attack, there's no wire to pull. There's no pull the plug solution. AWS obviously has, or most cloud providers have security controls in place to prevent flooding and stuff, right? And you can't, like, for example, do broadcast traffic within VPCs and things like that.
yeah,
So there are these security precautions already taken care. Your ping of death and all those obviously will not no longer work in even on-prem systems now. But back then it was crazy, because all you had to do was pull the wire and things would become normal again in some time.
yeah, yeah. I mean, in my experience, right, I feel like the internet exposure
Ah,
increased drastically after
ah,
the cloud public service cloud providers came into the picture.
yeah,
Because earlier, right, if you are running an application, that application, in order to get that exposed to the internet, in enterprise organizations at least, what will happen is you need to go ahead and submit a change control request. That
Oh,
change that request will go to the firewall team. They will approve it, whatever it is, and then the security team will check or whatever it is, and then the network team will go ahead and properly open particular port and whatever it is required, they will open it. It's now how it is right now is it's
one command.
infrastructure. One command or one YAML template or whatever it is. I mean, they always there's a famous saying, right? You're one YAML template away from
Away from
getting
yeah,
your Kubernetes cluster getting breached.
yeah.
So it become that easy. So that's one. The internet exposure drastically increased. That's the
Yeah,
first thing that I always feel.
yeah,
That's always for the good and also for the bad sometimes. Majorly for the good. I love the cloud native stuff compared to the
yeah,
previous things. On the
yeah,
other side, I also feel that there is a huge API exposure as well. Yes, in terms
yeah,
of the number of APIs that are exposed to the internet for an application, in terms of administrative, in terms of management, whatever it is, that got drastically increased. And in terms of pen testing, right, I was doing pen testing not at a professional level a lot, but it's at a script kiddie level a lot back in my school days. So at the time, it was all like there are a lot of WHMCS servers, and those WHMCS servers will be hosting hundreds on thousands of websites. So you can always pen test those WHMCS servers, which is basically one server running hosting
yeah.
hundreds or hundreds of server websites in it.
cPanel. Yeah,
Yeah, cPanel. So once you get that access to the WHMCS, you get
yeah,
access to hundreds and thousands of cPanels sometimes,
yeah,
and that's pretty much it.
yeah,
Compared to it now, it's the attack paths basically are drastic. So the attack path is like now you enter an web application, and that web application maybe can be running on an EC2 server. That
yeah,
EC2 server is having some the IMDS version
yeah,
one that you have mentioned.
yeah,
It's
yeah,
open, and then the AWS access keys goes back to the user, and then they go and access S3 bucket and whatever the other cloud services that server has access. So these are some things that I always feel that okay, back in those days, like 10 years, 15 years back, the pen testing was different, and now the pen testing is different. But one thing that always kept me unique, I mean, same thing is that hacker mindset kind of a thing. Something or other there is a vulnerability. So we just have to keep testing it some at multiple endpoints.
yeah.
Definitely, we'll find that loophole or entry point. Once we get
Yeah.
that entry point, it's like football inside the environment. So
There's that saying, no, that an absolutely perfectly secure system is completely unusable, right? So,
yeah, yeah,
as if you want your services to be used by other folks, there are
yeah,
going to be security flaws that will creep in, right? And you've kind of made me nostalgic about a lot of other things that happened 15, 10 years ago. And so Akash has this saying. I'm sure it's a saying on the internet, but I've heard him use it more frequently than anyone else. That uh, it's the whole cattle versus pets or cats perception, right? Cloud servers now, any infrastructure on the cloud is like cattle. You can have and spin up and destroy and as many. Earlier, on-prem servers were pets. You had to take care of them. You have to do manual updates. You have to do patching. You have to make
yeah.
sure that there's no dust on those servers, right? People had to, there was keys on the racks and stuff like that. So you have to take care of your servers. Patching, servers, firewalling, your apps have to be put in proper directories and things like that. Now you spin up, if like, for me also now, if I'm doing something and if I spin up an EC2 instance and I'm trying to SSH to it from my home system, home internet IP address, and for some reason it is not working. I don't spend time troubleshooting the internet gateway or routing tables within AWS, although that's the right way to do it. But I just switch to a different region and I spin up a new server and SSH. I need to do what I need to do instead of banging my head with network tables and routing tables. Although that's the right troubleshooting if I was doing something on prod, right? That's always a fun way to look at it.
Yeah, and Arunish has a point here. I mean, hey
Yeah,
Arunish, thanks for the comment. It's like he also mentioned, like the extension of being cloud enabled is increased usage of SaaS services.
yeah, yeah,
So
absolutely,
I
absolutely.
mean, one cloud provider is typically having a lot of integrations in terms of IDP, in terms
Yeah,
of connecting with other VPCs. On we use like some other cloud provider for cognitive services and some other cloud provider for our serverless functions. So we use like multi-cloud, and we also use a few SaaS applications integrated to one of the cloud provider environments. So with all this SaaS coming into the picture, already AWS has like AWS and Google Cloud and these type of public service providers have at least 300 services each,
Oh,
and each of those services will have at least 100 or 200 APIs in it.
yeah,
So
yeah.
to make it much more complex, what they're doing is like they are integrating these services with the Datadog or whatever it is. They're integrating with all these other SaaS services, which is like a never-ending game. I mean, from there, from that SaaS service, it goes to somewhere else as well.
Tell
So
me about it. Yeah, tell me about it because I mean at Cloudl, that's one of the primary roles that I have, right? And keeping up with different APIs that different services, different APIs that cloud providers, you know, keep coming up with. Like this week, for example, AWS will launch something. 4 weeks later, Google has already done their survey to see if they can steal customers. So that's always that war is there. And then we are stuck here. I'm reading the documentation for AWS, trying to find threat model the service, figure out misconfigurations, add it to Cloudl so that our customers can go and then scan their AWS. But what happens in that time is the service has added two new whatever features, which Google Cloud doesn't have, right? So that
yeah,
fight is never going to end, and
it's
we're
never
only going
ending.
to play catch up. Yeah, exactly. We're only going to do catch
I
up
mean,
at that point in time.
what it's sometimes it's a bit easy for I mean, you're doing it for Cloud and I'm doing for Risk Profiler, Priyas.
Mm.
So what you do is like you do that research and give it to the developers.
Yeah.
And in my situation, what I do is like I find some external vulnerabilities, and then
Uh,
how that external vulnerability can lead to one cloud service, and from that cloud service how it goes to the other cloud service. I do that research,
uh,
and sometimes I feel like doing that research is much easier than building that signature by the
yeah.
developers.
Yeah.
So
Yeah.
what I just create that attack path with all the configurations, and then I just give it to my developers. Please go ahead and
Uh,
build it for risk for cloud attack surface management.
uh,
And they will for me the research that takes me one day, it will take
mm,
them like two sprints, basically 1 or 2 sprints, which is like 2 weeks of
mm,
time.
uh.
So now I have like 78 signatures to be developed, whereas they are like backlogged for the next 2 months with just those signature implementations.
Let's not talk about backlogs.
Yeah, exactly, exactly.
Whatever that is. Yeah.
Yeah. Yeah, I mean, follow up with that, right?
Mm,
This is basically like the cloud native services are mostly distributed, right?
mm.
So, how does this distributed nature of cloud services impact the management and mitigation of the external threats, Riaz?
Uh, I mean, there are multiple perspectives for this question, and we're looking at management. First, we're looking at impact, right? First of all, even discovering that so and so misconfiguration can exist or so and so vulnerability may exist. I have seen in my experience building Cloudl as well as testing, pen testing at AppSeco, and even before that, depending on where, right, the or even depending on how the management looks at this, cloud security and threat management is not the primary focus for a lot of teams, right? Unless you have a dedicated SOC, for example, right? And this is crazy because for a small team, their threat identification is limited to saying, "Hey, is my customer's data secure?" Right? That's what they're focusing on, or something around the terms of is user authentication set up properly or not within the app that I've built on top of my cloud infrastructure, right? Authorization challenges are not addressed, resulting in I have seen overprivileged roles in apps in the cloud provider itself, right? In the IAM itself, we've got cases where AWS EKS, for example, the user that has created the cluster has admin privileges, and any other IAM admin user will not have any privileges within the cluster, right? Because IAM binding roles have not been created. The overprivilege occurs when the cluster administrator gives access to all the IAM users within the context, right? That's always common.
Yeah.
Large enterprises, however, who have dedicated SOC teams and all kinds of tools and bells and whistles, they lack threat contextualization, right? Because that's not very well understood, and that's something that I think you do within your product. It's interesting because we've had cases where we've had to lower the severity of an S3 bucket being public simply because the data that was within the S3 bucket was not sensitive, right? And uh, although from a CVSS score calculation point of view, it was critical because I can read all your data within the S3 bucket. But it wasn't images of CSS or JS, but it was still sensitive in our context. But in the company's context, it was not, right? So distributed nature of cloud services makes it a little more tedious, they for management and mitigation of threats, right? And infra admins tend to solve things at the cloud layer, for example, slapping a firewall to say a port that is open, right? But if the threat can be manifested through an IAM credential, then your firewall is of no use, because your IAM can be used to gain access to the EC2 instance itself. Right? I've had that case with during a pen test where we said that your EC2, one of the apps that they were supposed to run internally was exposed to the internet, right? And they made that private, right? But there was another API endpoint that they were like, this is required, and that API had SSRF. Using that SSRF, we were able to pull out credentials. Using credentials, we became, which was private, right? And
Yeah.
they were like, how did you do this? I was like, yeah, because you fixed what you think was visible to the internet was a
Yeah.
problem. 22 was closed on the internet, but I was able
Yeah.
to use SSM in AWS and run commands and get a reversal. Right? So not
Yeah.
technically SSH, but I had code exec access to the machine. So distributed nature of cloud services is one way to look at it, but depending on the context of your organization,
Yeah.
managing and mitigating external threats can become really a task intensive process. you
It's
require you require
right.
resources to be dedicated to do this. I'm sure you've
Yeah.
seen that with your customers.
A lot. I mean, we have seen it internally as well, right? At Risk Profile as well. So, for
Yeah,
example, right, we have seen, because at Risk Profile it's totally serverless,
yeah,
and even if we have like, we run containers, but it's we run Kubernetes, but it's like managed
yeah,
Kubernetes, EKS kind of stuff.
yeah,
So even in EKS, what we do is like we do serverless functions in EKS,
yeah,
because the type of use cases we have, sometimes we have to go ahead and give that to the we have to deploy to the customer's environment, because customers don't want to go ahead and share their cloud roles directly with our platform, whatever it is, their preferences.
yeah,
So in those type of situations, we have seen these complexities. Basically, if we have a Kubernetes cluster,
yeah,
that Kubernetes cluster, if you go ahead and tighten it up, whatever it is,
yeah,
always there are like, at least if there are 100 pods running in it, out of the
mm,
100 pods, there are like 20 to 30 pods that do have access to the cloud services that are outside that EKS cluster.
yeah,
So that pod can have access to RDS database. That
yeah,
pod can have access to S3, whatever it
yeah,
is.
yeah,
So now, if an attacker compromises an Kubernetes cluster, it's not that the attacker only get access to the stuff that is inside that Kubernetes cluster, and it goes outside the Kubernetes cluster as well, because these pods having access to the cloud services. And this type of headache is it's a pain basically. I mean, and
mounted
first of all,
secrets is mounted secrets is like the Achilles's heel of securing a cluster. I've seen people overprivilege everything within clusters, right? And
yeah, yeah.
that's
And
always interesting.
with all this like distributor stuff, like one is over here, one is over here, when all these things are interlinked together, I mean, it's not a simple thing without a proper solution in place that can clearly tell you like, okay, this is your attack path, this is your visualization, and by just reading the configuration files, it's very hard sometimes. So we
Yeah,
need
it
that
is.
graphical representation of nodes, entities, relationships, and those type of things to
Uh,
understand this attack path better and quickly take some resolutions out of things.
it
So
is.
these are like one or two things that are always. Even I went back and I was reading the research that was published around the Kubernetes security from Wiz. So
Hmm,
what those guys tell, I mean, they submitted like a 40-50 pages of Kubernetes security white paper
hmm,
and highlighting a lot of things. Out of those 40-50 pages, there is one page that says executive summary.
hmm,
In that executive summary, they didn't have like 10 or 15 recommendations for the executives. They had
hmm,
only like three or four recommendations.
hmm,
Out of those three or four recommendations, when it comes to Kubernetes for executives, the first recommendation is they say like continuous scanning of external exposure and
hmm,
externally facing resources that are Kubernetes resources is the first important thing.
hmm, hmm,
And
hmm,
again, the second thing as well, they claim about it like detection and remediation of critical vulnerabilities in public exposed Kubernetes servers. So both out of the three or four recommendations that they gave to the executives, out of a 40-page report, 50 or 60% of them are only for external threats.
Yeah.
And then it's like I understood like, okay, these guys are like, it's a company that went from like 1 million to 100 million at like within a year or something. And
Mm.
these guys did that kind of an audit over thousands of Kubernetes clusters, and they came up with two very very basic recommendations, but very very impactful ones,
Mm.
and both are around external threats. And
Yeah.
that's I thought like, yeah, I mean, it's a big problem, and there are
Mm.
not many solutions that are doing proper thing. So that's when I thought like, let's build a proper cloud attack surface management. And then we started that module, which barely any of
Mm.
our fellow cohorts have right now in place.
Mm. See, the step one to for attacking as well as
uh,
defense, right? So step,
yeah,
I always say this when I'm teaching like a pen testing class. Uh, an attacker needs to know, or rather, an attacker needs to see, right? Because otherwise, if you can't see, you can't send traffic to it, right? That's the whole idea.
yeah,
And the only way to break into stuff is by sending traffic. All
yes,
attacks require the TCP layer at some point in time. The thing is that an attacker, to be able to see, they discover stuff, right?
yeah,
But infra folks who have access, right,
yeah,
they can create inventories. And
yes,
that's something that cloud does before it does a misconfiguration detection. It actually creates an asset inventory of your entire cloud, right? So
yeah,
it figures out what your S3 buckets are, your EC2s, and things like that, and then goes and discovers misconfigurations. The we built the asset inventory module first, because
yeah,
even when the product was in early stages, customers would be like, "Hey, I don't know what all is running within my
yeah,
environment." And it's a very very valid question, because I'm sure your customers also have come to you and said, "Ki, you're telling me about external threats, right? And
yeah,
I need to know what these external threats are. But hey, I am also clueless about what my internal inventory is,
yeah,
right?" So that's
yeah.
always there. Solving both sides of things is really important.
It is. Totally agree. Totally agree. And I have this buzz and also
Oh,
very
zero
powerful
trust.
one. Yeah, exactly. I want to touch base on it. So, uh, being on the offensive side, right?
Huh.
What is something that you felt like, if these security controls are implemented in a Kubernetes cluster, it
Hmm.
makes the penetration testers' life hard? What are those things basically?
Well, obviously, this is coming from personal experience, because I've had more hard cases than I've had fun engagements. A lot of times, clusters have been so well set up, so well configured. The the architects may not know, or they may not use the term zero trust architecture, but they've implemented all the principles,
Mm,
right, and
yeah,
all the
yeah,
major principles within ZTA. And two of my favorite ones in there are assign the least privilege required to get the job done,
mm,
right? That's my one of my favorite ones, right?
mm,
It's like, you don't need to give admin credentials, or you don't need to give admin privileges to a pod that is only supposed to spin up and say read a file from a particular S3 bucket, right? If the pod is required to only start spin up read a particular file from a particular, or a particular extension from an S3 bucket, you can have IAM policies created to an extent where you can read only specific files within a
mm.
specific bucket, right? And
Exactly.
using advanced policies, you can even create more granular controls. The
Yeah.
idea is that assigning least privileges at that level allows, even if an attacker managed to gain
Mm,
access, they're
mm.
about they're just there. They can't do much, right? Then they're like, oh,
They
I
can't do
found an S3
shit.
bucket. Yeah,
Yeah,
you can't see stuff. There's no
yeah,
LS. The S3 enumeration is not possible, right?
yeah,
List buckets is not possible. They can only go particular bucket and read stuff or particular type of file, right? And that
yeah.
itself is a good way to get started with things like the idea of least privileges for systems, reducing the attack footprint, right? Discovery of obviously the attack footprint, and then reducing the attack footprint. Your API, your primary control plane API server, if it's not supposed to be visible to the internet, then don't, right? But keep it internal. While setting up the cluster itself, make sure that it is in a private VPC instead of creating a public and then adding a firewall, right?
Yeah.
If the cluster is never going to be public, then don't do it. I've seen architecture setup where infrastructure setup where there's a pod that is connected to reading data from an RDS instance, but the RDS instance is in US East 1, cluster also is in US East 1, but the pod is connecting to the external IP address of the RDS. So traffic is leaving the cluster to the internet, reaching the
And
same
then
region,
coming back from
and
the
then
internet.
coming back. You latency ka to main baat hi nahi kar raha. I'm not even talking about how slow this becomes, but the
Yeah.
idea that and again, there's a bug I had reported with AWS RDS that they don't by default enable SSL TLS on connections, right? And AWS hasn't, they won't fix it because by design required for older customers. The important thing is that I can write code as a dev, as a horrible dev. I can write code that I can connect to an RDS and not have SSL TLS for my connections. If you're doing that over the internet, then again, you have unencrypted data flying around, right? So that's a thing. So micro segmentation to a bit like VPCs, for example. That's my second one. Least privileges being one. Micro segmentation. Make sure that only stuff that is required for a current exercise or task is what is there in your, uh, your architecture. Like, don't
Yeah.
keep unwanted stuff. I've seen people have clusters and setup ready, but there are also references to, Fargate and older clusters that they were running, older architecture that they were using, right? And that's not been deprecated. Although it's been deprecated in the system, but the code is still there, right? Um, MFA also comes to mind, right? And I've seen if you have OIDC enabled systems, if you have multi-factor authentication set up, there wouldn't have been ways by which I would
Yeah.
have been able, unless I was doing a targeted phishing attack to somebody and or sniffing their GSM data on their mobile phone sitting next to them. I wouldn't have been able to bypass whatever access I had at that point in time. So uh, bunch of these things. These three are the top things that I think about. ZTA is a full day discussion if you can. And most conferences these days would talk about zero trust architecture. The idea is the same principles that we have been applying for 10, 20 years. Least
Yeah.
privileges, you segment stuff to the extent that it is only supposed to have access to what it is need to have access to, need to know
Yeah.
basis, and your multi-factor authentication, right?
Yeah.
You've been doing this for 10, 15 years. Zero trust architecture is the new marketing gimmicky
Yeah.
concept around this.
I did the same thing because back like we always had authentication, we always had authorization, we always had network segmentation, micro segmentation. You mentioned service meshes were there,
Yeah.
and so all these things were there. But making sure using all these things. I mean, one thing which I always me see, I did wear the hat of a penetration tester, and right now I'm wearing a different hat of building things.
Huh.
So it's easy when my previous role was always easy, Priyas.
Hmm.
The
Hmm.
current role is a pain. The reason is I know that it's very important to make sure I create an IAM policy or some kind of Kubernetes manifest, which is like fine grained. Okay. If I make that fine grained kind of a policy, the amount of rework that I have to do every time, it's it's not a simple thing. And sometimes if I go, I mean, I have restricted it to the bucket kind of a level. Now this
Huh.
pod needs to access different bucket.
Huh.
So I go back, change it, and then keep on adding it.
Huh.
So in terms of these things are simple because these are the things which I am doing. The thing which gets it complex, when an application grows, the number of services grows, and these services are interlinked with each other. So I have built an IAM policy to let this pod only communicate and access to one particular bucket. I have restricted it. Now there is one more policy that I have built, which is crashing for some weird reason. And then
Hmm.
when once we finally did dig the root cause, it is because that the pod is trying to communicate with this service, which is not having the access for the bucket. And
Hmm.
especially when you don't have this centralized logging kind of a thing. I mean, gladly we have some good Datadog kind of a solution right now, but if we don't have that kind of proper logging in place that tells you the service to service communications,
Hmm.
it would take like 3 or 4 hours in just debugging that.
Troubleshooting. Yeah.
Huh. And, it's complex. I mean, I told you, right? The number of APIs that a single service has
Yeah.
versus creating a granular policy, and
Hmm.
we exactly don't know. Like sometimes we don't know that what are the exact API calls that are required for one service to communicate with the other service to get X, Y, Z job done. We will, I mean, I assume like okay, list and read is fine, but then comes a different API which is like a prerequisite kind of a thing that will be hidden somewhere in the documentation that I have to go out and add to get that work.
Yeah, yeah,
So
yeah, yeah.
it's like every time I send the API request and then I'll watch the logs. Okay, what is the error message that I'm getting? Okay, the error message that I'm getting is okay, access denied, and then the API call name. Okay, this is the thing which I have to allow. So I'll go back,
Mhm,
allow there, and then come back, and then I'll run the request again. Now a new API call is not allowed. Go ahead
mhm,
and allow it, and then come back. Man,
mhm.
it's zero trust is nice, man. Authorization is easy, man. But
I think
the
I'm forgetting the name of the actual service, but AWS and Google Cloud both have Azure. I'm not sure, but AWS and Google Cloud both have inbuilt services that allow you to figure out what is required based on
IAM
failed
access analyzer.
API. IAM
Yeah.
Access Analyzer. Yeah, yeah, yeah. Based on your failed API calls. That's
Bro,
always
that
a
won't work for 6 to 7 hours, bro.
okay, okay. You have field knowledge, and obviously.
So that's like that. It has a delay. Basically, IAM access analyzer under the hood, it works. It runs the
Yeah.
queries and fine for this. It's like 6 hours, 6 to 8 hours kind of a
Uh,
delay. So man, it's anyways. It's zero trust is amazing,
uh,
and properly implementing zero trust is sometimes very pain, man. I don't
it's
know
a
whether there are some amazing enterprise solutions that are out there in the market, but there may be some amazing enterprise solutions that are out there in the market. But
see
at the stage, like,
all enterprise solutions that claim to do zero trust architecture and all now, they require intimate knowledge of how the architecture is set up first of all,
huh,
right? Because you can't simply come and plug in a solution and it starts automatically. Your enterprise will go down, right?
yeah, it
Because
will
it
go
start
down.
putting rules in places that are not supposed to have, right?
Yeah,
The administrator who installed the deployed the solution will be locked out from his own infra, right? So
yeah,
all of these require intimate knowledge. So which is why people who implement these enterprise solutions for zero trust architecture have 6 month long or 3 month long projects, right? So it's
yeah,
consulting slash product implementation that they're doing.
yeah,
They understand the infra, they create an inventory, then they identify users, they identify privileges, they identify where all what, even including apps, not only users, because service accounts and other principals are
yes,
also technically
part of it.
using credentials, right? So
Yes,
not only humans, there are also services, apps flying around. All of that has to be inventorized,
yeah,
and then they start segregating and adding whatever your principles for ZT is, and that is the solution that they're implementing. It requires a lot of hard work and deploying real humans to remote
yeah,
locations to do this, figure this out.
yeah, yeah. I remember like for like when we deploy a web application firewall, right?
Mm.
So we put it in audit mode for like 1 or 2 months. And then after monitoring it for 1 or 2 months, then we go ahead and put it in block mode after some due diligence. Still, it
Mm.
gets something or other gets blocked. I mean, the application goes down, and then we had to revert it back to the audit mode. And
Yeah,
then
yeah,
came
yeah.
all these next gen WAF solutions that does automatic all this fancy stuff. But I didn't see much success. The same thing applies to this. I mean, just for one application. Now, what you are saying is, imagine for like hundreds of applications, hundreds of users, servers at an enterprise level. I don't
Mm.
know when it will go into complete fraud mode, but anyways. So I have a question, like which is
Mm.
like we have been doing a lot of attacker side of things. Like in terms of a defensive side of things, like what are
Mm.
some best practices that you normally recommend, Riaz, for logging, monitoring of these external threats way early in the cloud environments?
Oh, my best practices might not be field tested, okay, but I'll tell you from some of the things I've seen in the industry. I can't do a lot of defense work, honestly. My brain is wired like that. You tell me to find a flaw in that defense wala thing, I'll probably
You'll
do
find it. Yeah,
it. But I've seen stuff. I've seen folks do this. The best, I mean, it depends on the cloud provider also. The best tools that are available for logging and monitoring is very likely the tool that is provided by the cloud provider themselves, right? And because they have access to undocumented APIs, for example, which third party tools may not have. But like most things within cloud providers, the best, most capable tool has like the shittiest UI, right? So
yeah,
if the product is unusable from that point of view, right? From
yeah,
the If the product is unusable from that point of view, then the usage goes down, If the usage goes down, then people will stop doing logging and monitoring entirely, and then you have a whole can of worms that will open up. Um, the Some of the best practices I've seen, and I've also spoken to folks that who actually do monitoring and stuff, is to look out for the obvious signs, right? Like your CPU spikes, for example, or if you suddenly see like a large, outbound egress data moving out from your VPCs. You can have alarms for all of these, by the way, right? In AWS context, I'm talking about. If you see a lot of failed API attempts, if too many 500s or 403s are being returned, for example, um, attempts being made by limited privilege users to areas that they're not supposed to have access to, right? So,
Yeah.
um, like limited users trying to do create pods and things like that. STS calls for STS get caller identity in a lot of places because that's an attacker favorite way of figuring out who I am if I stolen credentials. Too many pods starting, failing, restarting, right? And image pull fails. Can has the node been modified? Has the container been modified to access other apps? Things like those. Any modification for or sudden spike in traffic between namespaces, between pods, for example, that you would not expecting, right? So keeping a lookout for all of these things is I would consider to be best practice, or like things to do when you're looking at it. The essential part about logging and monitoring is what do you do with the logging and monitoring that you have in place if there is no action taking on the logs that you've accumulated, right? Which is why logging is not everyone's cup of tea, because there's a dedicated human or dedicated system required to be able to parse and understand anomalous behavior and take immediate action, right? It could be a system, could be a human who's simply going to go switch off all the systems that are on, or pull the plug in our cases, right? If there's no action taken on the logging bits, then your whole idea of logging itself goes down. Uh, Another recommendation I always give to folks is how do you keep the logging data, right? Because your logs then become evidence in case of incidents response and forensics. So make sure your logging data itself is set up properly in a protected S3 bucket, and you have MFA delete and other things set up. But no delete options available on these buckets and things like that on the data that's being written, right? So keeping sure that making sure that the tampering or the integrity of the data is secure, right? Um, One thing or more, these are some of the common things that I have in open discussions. But what to do with the data and how to ensure that the logging data itself is not tampered with is our key, and also on what to watch out for in the logs. So,
Nice. I mean, it's getting telling centralized log management is easy, but sometimes it gets complex with all these different services. I mean, at least we were in a far. I feel like we are in a far better situation compared to the traditional data center days. Riaz.
yeah,
Reason is, for
yeah,
example, if we want to go ahead and log all the console activities, service to service activities right now, it's just a simple button. Go ahead and enable logging in the public service cloud provider, and then you get all the logs beautifully collected and stored in one different place. And this was a like full-time job back then, where
yeah,
the operation center guys, they struggle a
yeah,
lot to get all those logs aggregated from. And one day they'll complain like Windows servers are not reporting logs, and the other day it's the Linux servers, and another day
yeah,
it's the endpoints, another day it's firewalls, and one day it's
yeah,
IDS. So something or other things get failed. But now we are
yeah,
in a beautiful luxury that
uh,
these things, once we configure them, they're
yeah,
beautifully coming and falling in respective buckets.
yeah,
But then the problem starts. Like now we have a lot of data.
yeah,
What to do with this data? So
yeah,
that's where I feel like it's complex. Man, writing the signatures in terms of understanding what are the things that we care
yeah,
about. First of all, what we
yeah,
need, what we don't need. Those things are important. And then shipping these logs, because these things are sitting in a bucket, but
yeah,
we can't use typical solutions to query those logs in those buckets. We have to go ahead and move them to a different solution, and in that solution we have to create monitors.
yeah,
So
yeah,
if you ask me, what is the best practice to monitor your external threats? I mean, shameless plug. I'll tell like use Risco folder to understand what are your all your exposed resources in your cloud environments. But
yeah,
apart from that, there are we can always do like an inventory of the assets that you have mentioned. So once we have the inventory of the assets, we know what is the configuration of those assets. So from that configuration of those assets, we will know in terms of like, okay, these are the assets that are exposed to the internet based on the configuration of those resources. We have that
Hmm.
information. So then comes a little bit problem. I mean, a small problem. The small problem is like this is purely a configuration kind of alerts. So if there is an EC2 server which is having a security group attached to it with 0.0.0.0, according to this configuration assessment that most of the cloud security posture management solutions are doing, what happens is it says there are 100 EC2 servers that are exposed to the internet. But when we think about the context in terms of is this in a private subnet or is this in a private VPC or is this in an inspection VPC? Is it in behind an egress only internet gateway?
Hmm.
When we talk
Hmm.
about several of these context kind of things, it becomes a lot of validation that we need to do within the
Hmm.
configurations itself.
Hmm.
So that's, I mean, once the better way of doing it, like once you have this inventory, go ahead and validate it from the outside in.
Hey, send a packet.
Yeah, send a packet, and now you'll exactly know which of those resources are actually public and which of those resources
Yeah.
are not actually public.
Yeah.
So, and then comes the another small problem. The another small problem is inside the VPC, it can be a NAT gateway.
Yeah.
So the IP address it is seeing can be totally different versus the IP address that this server is having behind the NAT gateway. So that's another problem. So I mean that's why we I mean that's the reason I told in the first place use risk profiler. But in the coming back to the original stuff, right? It's always very important and also sometimes headache to create all
Hmm.
these monitors and signatures and alerts. I did that because I did that for our cloud environment and
Hmm.
bombarded with the number of alerts,
Yeah.
and then we thought like we need some cleanup and all these kind of things and did all the maturity kind of things to make sure we do that. On the other side, when it comes when we are talking about Kubernetes, right? I
Yeah.
always believe that it's very important when you are having a Kubernetes cluster, every cloud provider have some kind of IDS or IPS in place to monitor those Kubernetes audit logs by default.
Hmm. Hmm.
So please go ahead and turn that switch on so that you
Hmm.
get some basic protection within the cloud environment is what I would normally suggest.
Hmm.
And there is also something that comes which is more around SIM. So in
Hmm.
SIMs, right, I don't understand one thing. We get the logs from the Windows servers which are on the data centers. We get logs from the Linux server on the data center. We get logs from the endpoints from the workstation. I don't understand why in the current world I'm not seeing a lot of organizations pushing the application logs as well to the SIM application logs, at least in the Kubernetes audit logs, or else API gateway authentication kind of calls. So at least
Hmm.
those type of things have to go into the SIM as well,
Hmm.
because without that information in a SIM,
Hmm.
how many ever monitors we write, they're not going
Hmm.
to be useful because because SIM in the current world it's all about contextualization, normalization of the data, and
Hmm.
uh, mapping one fact. I mean one request with the other
Yeah.
second, third request. It's all about that's what SIM does, right? If it has
The
information, it's a pain as well.
the reason could may not be a technical reason that if you've not seen rather app logs being sent to sim solutions, right?
Uh,
I have seen in some cases, but again, as you said, in a lot of cases they don't send app logs. They're happy with workstation logs and physical on-prem server logs coming to sim. uh, the reasoning behind that could simply be political in terms of who's managing what within that department, right? Because if you're doing something in Kubernetes, then it is DevOps. That's a separate team altogether. If
yeah,
you're doing stuff on on-prem Windows and Linux and workstation, then it is the company IT team, right?
yeah,
And they will manage the sim. We don't want logs coming from your Kubernetes cluster. We don't understand what is going to come. It would
yeah,
overwhelm us sim, and our protection that we've enabled on IT enterprise is going to go down. So the
yeah,
reasoning could be political in that sense, right?
yeah.
But
It is.
I think, yeah, you mentioned a good point, and we have to be conscious about time. Also, to kind of overstep. But okay, this is a fun conversation that we have. We should do this more often. Do the thing that you mentioned about looking at it from outside and inside and ensuring sending the packet to figure out if the system is visible or not. Uh, this People have been doing this for quite some time, right?
Yeah,
Identifying what is open allows the attacker to move to step two, right?
correct.
And you can hide behind firewalls and stuff, but there's going to be, unless it's a requirement and you've not placed your firewall rules based on your business requirement, you will end up with exposing service, right?
Yeah.
And businesses keep open up firewall rules arbitrarily, especially when people are working from home, for example, right?
Yeah.
If you want to SSH, you start with one IP address, and not everybody uses static IP addresses at home,
Yeah.
right? If
Correct.
if they have VPN, then VPN is a good option because then you work with only one IP address. But a lot of
Yeah.
companies, small companies, they don't use VPN. They just allow people to SSH from their home IP addresses, which keep changing. Then you
Yes.
end up adding new firewall rules every day,
Yeah.
right? that
Yeah.
that's a fun bit.
It's a never-ending process kind of thing.
Yeah.
And I mean, I totally lost track of time, Riaz,
Yeah,
because
dude.
I mean, whenever I like,
Yeah,
I mean, whenever I like the conversation or I enjoy the conversation, I have a very
yeah,
bad habit of
yeah,
not keeping track of the time, and
yeah,
it happens several times. I mean, I even miss my meetings, which are like following. I always I miss it a lot.
yeah,
So I mean,
yeah.
first of all, I mean, I
Yeah.
just want to thank you, Riaz,
Sure,
for taking time and
sure.
giving and sharing all your insights. And I also
Absolutely.
would like to thank all the audience whoever have joined us and also asked amazing questions during this webinar. So thank you so much, guys.
Sure, folks. Take care. Bye bye.
Yes, bye bye.